Today we're going to be looking at area formula, so specifically how we can find out the area that a rectangle takes up, a triangle takes up, parallelogram takes up, kites take up, trapezia take up, and circles take up. I will explain why we use the formulas that we do, and you'll get to see them in action. Let's start. Let's start with rectangles, because that's the easiest one, and this is probably a lot of revision for you. We know that with rectangles, or for that matter squares as well, we have two lengths. We have a length here, and we have the width of how high or how wide it is. So we've got length and width. With a rectangle, the width will be the same on both sides. On the length, it'll be the same on both sides as well. Working out the area for a rectangle or a square is quite easy. All you do is, for area, you do length times width. So we get the length here, the width here, times them together. That's how much area that space, that object takes up. Moving on to something a little bit more tricky, but still quite easy, is a triangle. For a triangle, we'll usually have two different measurements. We have the height of the triangle and we have the length of the base. So, height, how high is the triangle, and base, how long is the base of the triangle. Now, before we go any further and I tell you the formula for a triangle, I'd just like to draw and show you, if I was to extend or add a second triangle, exactly the same triangle, on top of this triangle, I have a rectangle. To work out the area for a rectangle, all I would have done is base times height or length times width. So if a triangle takes up half the spot that the rectangle would, it makes sense that the formula for a triangle is going to be area equals half base times height. If we just did base times height, we'd be working at the area of the entire rectangle. We times it by a half because it only takes up half that space. We have another triangle here that's missing. Moving on to yet another shape, we have a parallelogram here. Now, some of you may not have seen a parallelogram before. We call this a parallelogram because it's basically made up of two parallel sides. We've got parallel sides here and another set up here, hence a parallelogram. It's also basically just a squashed rectangle. Now, again, we have two units here because remember, all area, we only deal with two measurements. So we have how long is the base of the parallelogram, and we have how high is the parallelogram. So notice I'm not looking at the length of this slanted part. I want just the base and how high is the parallelogram. Now, before we continue, again, I'd like to draw on this shape. So where I've done this dashed line here, let's pretend I'm cutting that off and I'm putting it over here. Again, if we just look at those red dashed dots, I have a rectangle again. And the area for a rectangle is length times width. So my length for this rectangle is base and my width is height. So the area for a parallelogram is just going to be area equals base times height, or BH. Let's have a look at another shape. This is one that you might not have seen before. It's a kite, and that makes sense because it looks like a kite. With the kite, we're not interested in the length of the sides. Instead, I'm interested in how high it is. So we call this Y. Okay. So from the apex here to the apex here, how high is this? How high is this? And from this apex to this apex, how long is the kite. We call that x. To work out the area for a kite, it's important that we can see some patterns in the kite. So, for example, I have a triangle here, a triangle here, a triangle here, and a triangle here. Now, we also have a triangle here, and a triangle here. Let's focus on those last two triangles. So, here and here. If I was to find the area of this triangle, it would be half of y times x. So half base times height. Half of half y times x. Same for this one. It would be half of y times x times a half. Essentially, I've got two triangles here. So the formula is going to be half base times height. The base is x. For both triangles, the base is x. For the height of each triangle, this is y. This is half of y. This is half of y. If we find the area of this whole shape, half of base times height. One big triangle, basically. So, the final formula for a kite, and sorry if this is getting confusing, if you just want to remember the formula, that's fine. The formula for the kite is area equals half x times y, or half x y. This shape that we've got here is a trapezium, or a trapezia. Okay. Now, it's important to note we have a height, and we have two different lengths. So we've got the top length here of A, and the bottom length here of B. Now, they're different lengths. That's a trapezium. It's got a different top to a bottom. They're not the same length. That's important. Okay. Again, I'm going to pretend that we're cutting this shape up. So let's pretend that I'm cutting it on this dashed line. And I'm going to flip that cut piece of paper and I'm going to place it over here. Okay, so again, we're just looking at this red rectangle here. So we're going to have essentially a length times width situation for this area. But I don't know how long this is, because this is A plus part of B, and this is part of B. I don't know how long this length is. I've got the width. The width is the height. That's fine. Sorry about the bell. To work out the length here, I have to find the average length of A and B. Of A and B. So how do I find the average? I add them together and divide by 2. So my formula here is area equals length times width. My width is height, that's fine. But my length is the average of A and B. So A plus B over 2, so this is the length, times by the width, which is height. So the formula for a kite is A plus B over 2 times height. The last shape we're going to look at is a circle. And I'm not going to go into why the formula is, I'm just going to tell you the formula for a circle. To find out the area of a circle, the formula is pi r squared. So pi times by the length of the radius, which is from the centre of the circle to an edge, squared. So pi radius squared. I hope this helps. I know it's been a little bit confusing with all the different shapes. Hopefully you understood it. If not, have a look in your textbook or we'll go through them again next lesson.